Determine whether the sequence converges or diverges. If it converges, find the limit. So here we're given a sub n equals the square root of n plus 1 over 9n plus 1. How are we going to go about this? Now, what if you'll notice is we can actually take the limit of this, and that will give us more insight as to whether or not this converges or diverges. So let's go ahead and do that. So we'll take, as n approaches infinity, the limit of that, right, of a sub n, which is the same as the limit as n approaches infinity of this big piece right here. So let's go ahead and do that. The square root of n plus 1 over 9n plus 1. Okay? Now, how are we going to find the limit of this? Now, what you'll notice is that within our square root, we have a numerator and a denominator. And we have some extra terms. So it's not just one term, we have two terms. So if I go ahead and go back, you'll see there's 1, 2, 1, and 2. Now, as this approaches infinity, the smaller terms are going to essentially be neglected. They're going to have a very little effect on the actual problem. So what does this mean? We can try direct substitution. So if we have infinity plus 1 over 9 infinity plus 1, this is essentially going to be infinity over infinity. Now this is an indeterminate form. We can't work with this. What we can do is use L'Hopital's rule, and that can help us with this indeterminate form of ours. So again, direct substitution doesn't work because we're going to get infinity over infinity. Now what L'Hopital's rule says is that if you have infinity over infinity, what you can do is take the derivative of the numerator, the derivative of the denominator, and you can try finding the limit of that, and that should assist you. It doesn't always work, but sometimes it does, so that's a good rule to know. And sometimes you'll have infinity times infinity, or infinity to the infinity power, and so forth. So you can always convert it back into this form right here, infinity over infinity. Take the derivative of the numerator and the derivative of the denominator separately, divide them, and find the limit. So let's go ahead and do that. So what is the derivative of n plus 1? So if we do something like this, for example, well, the derivative of n plus 1 is simply 1, and the derivative of 9n plus 1 equals 9. So essentially what we have is the limit as n approaches infinity of 1 over 9 square rooted. Okay? Now what is 1 over 9 square root? Well, another way we can write this is the same as the square root of 1 over the square root of 9. Right? We're just using our power properties. And this is 1 over 3. And that is our final answer. Because the limit of a constant is that constant itself. And of course you can simplify it and do things like that, but this is our final answer. Let's go ahead and do another problem. In this problem we have a sub n equals cosine of n over 2. Well, let's go ahead and remind ourselves how the graph of cosine looks like. So I'll go ahead and draw a simple graph, nothing too fancy. We know that it intercepts the y-axis at 0, 1. And we know the lowest point is at every pi interval. So we can go do something like this, for example. And we know this point is going to be pi negative 1. And every pi interval is going to do that. Okay? Just not super important, but you know, that's how the graph of cosine looks. It oscillates, right? That's a fancy word you can use. Now, one way we can determine whether this sequence converges is by finding the limit. So let's go ahead and do that. We'll take the limit as n approaches infinity of cosine of n over 2. Well, if we try direct substitution, we have cosine of infinity over 2. Now, infinity over 2 is still infinity. We have cosine of infinity. Now, you know the graph of cosine is continuous, right? And it goes on forever. Just like I mentioned before, at every interval, it repeats itself. And so if you were to go on forever, again, this is not perfectly accurate, but it's going to alternate between 1 and negative 1, 1 and negative 1. And unfortunately, there's no clear direct answer what exactly is the limit going to be. So in that case, it's indeterminate, and therefore it diverges. We cannot find the limit of it. Let's do one last problem. Now we have a sub n equals n squared times e to the negative 7n. Now how are we going to do this? Now if you have noticed that if we want to determine whether the sequence converges or diverges, all we have to do is find the limit. That's one easy way of doing it. And it's actually a 2-in-1. So if you haven't noticed already, when we find the limit, we'll actually find if it converges or not, based on the answer of that limit. So it's always a safe bet to just find the limit, and that will tell you whether it converges or diverges. It's not a separate technique or anything. So let's go ahead and do what we were doing for the previous problems. We'll take the limit as n approaches infinity of a sub n. And in this case, we have n squared to the times e to the negative 7n power. Now, using some clever algebra tricks, we can actually figure out that this is the limit as n approaches infinity of n squared over e to the 7n. Now, why is that? When you have a negative exponent like this, all you have to do is just put it on the denominator or the numerator, depending on where the starting position is, and you can remove that negative. So a classic example is 1 over x. This is the same as x to the negative first power. And likewise, if you have, for example, x squared, this is the same as 1 over x to the negative second power. Okay? So essentially, you put it on the denominator or numerator, make it negative, and that'll be equivalent. So that's exactly what we did with this term right here. We got it negative, and we put denominator, and now it's positive again. So that's good. Now, how are we going to go about this? Well, if we try a direct substitution, you'll notice that it doesn't work very well, because we have infinity over infinity, which is indeterminate. Okay. Now we could use L'Hopital's rule. You know, that's definitely not a bad idea at all. But if you notice, the denominator's power is higher than the numerator's power. And anytime this happens, as we approach infinity, this will give us 0. So that's one little clever trick to look out for. That's very nice. Is that when your denominator is bottom heavy, so you just look at the exponent, the term that has the largest exponent, it's gonna converge to 0. So that's very nice to know. And just in case, you know, this maybe the exponent is a little confusing for you, you can think of this, you can just separate them into like equations. For example, you have y equals 2 and y equals 7x, for example. So the 2 represents this and the 7x represents this. And if you were to graph it, just to, better understand things, you'll see that y equals 2 is about, for example, right there, y equals 2, and y equals 7x is something like this. Yeah, sure, for a little bit of time, y equals 2 is ahead of 7x, but in the long term, the 7x will beat out the 2. And in that case, what we can say is this is gonna eventually become 1 over infinity, which is 0. And it is convergent because we found an actual number that it converges to. Alrighty. And those were 3 problems that we just practiced. I try to get a variety of problems. And thank you very much for watching. If you have any feedback, please leave it in the comment section and please subscribe.